Alright guys, hello, my name is Jonathan Smith. I am here talking to you guys about section 8.4, properties of a rhombus, rectangle, and squares. Before we begin, I'm going to tell you a little bit about rhombuses, rectangles, and squares. A rhombus is a parallelogram with 4 congruent sides. A rectangle is a parallelogram with 4 congruent angles, or 4 right angles I mean. And a square is a parallelogram with 4 congruent sides and 4 right angles. Now, I'm going to tell you a little vocabulary. Now, an angle consists of 2 different rays with the same endpoint. The ray of the sides of the angle and endpoint are vertex and angles. So basically, it'll be like this, and the 2 rays will branch out, and that will become 1 angle. A right angle is an angle measured equal to 90 degrees. So this is equal to 90 degrees exactly. Diagonals is a segment that joins 2 non-consecutive vertices of a polygon. Quadrilateral is a polygon with 4 sides. Parallelogram is a quadrilateral with both pairs of opposite sides parallel to each other. And a congruent is the same shape, same size, basically. Now, let's zoom on over to the question. Over here is a multi-step problem that asks in the window shown at the right, line segment BD is congruent to line segment DF, which is congruent to line segment BH, which is also congruent to line segment HF. Also, angle AJB, BCD, DEF, and FGH are right angles. So, if we come over here, I'm going to start marking these off. So, segment BD, which is right here, DF, BH, HF are all equal to each other. Now, the angles HAB, which is a right angle, let's see, HAB, BCD, DEF, and FGH. Now that we have that settled, let's move on to the first question. Classify HBDF and ACEG and explain your reason. Now, the answer I got for this is that quadrilateral HBDF is a rhombus because the parallelogram has 4 sides that are all congruent, which is shown here. And quadrilateral ACEG, which is right here, the outside perimeter of the window, is a rectangle since the parallelogram has 4 angles that are all right, which is shown. Now, on to question B. What can you conclude about the lengths of the diagonals AE, which is from here to here, and GC, which is from here to here? Given that these diagonals intersect at J, which is the center of the window, what can you conclude about the lengths? Now, of AJ, JE, CJ, and JG. And explain. Well, the answer I got was that the lengths of the diagonals AE, side to side, GC, are congruent. Both congruent because that the rectangle window is congruent. The length of AJ, JE, CJ, and JG are also congruent because it's only half of the diagonal, and the diagonal of the rectangle is congruent. So, basically, in the end, they all bisect each other. Thank you.